That t-shirt you've got on right now? Yeah, that one. It's not just a piece of fabric. Nope. It's actually the end result of a super precise technical blueprint, kind of like a secret code. And today, well, we're going to crack it.
So have you ever really thought about it? How does a single piece of thread become the soft, comfy, stretchy fabric of your favorite t-shirt? It's not magic, I promise. It's a technical language, a code, and we are so about to crack it.
Okay, so here it is, the whole shebang. This is the complete technical blueprint for single jersey fabric. And when I say single jersey, you know exactly what I'm talking about. That classic t-shirt material, right? Super smooth on the outside, a little more textured on the inside. Now, I know it looks kind of complicated, but trust me, it's really just three key parts working together perfectly.
All right, so to really get this, we've got to start at the very beginning, with the most fundamental part of the whole thing, the pattern. Just think of this first piece of the puzzle as the fabric's DNA.
See this section over on the left? That's the fabric notation. This is our DNA. It's literally a drawing of the exact path a single yarn takes. See how it loops and interlocks with itself again and again and again? This one repeating motion, that's the absolute heart of the entire textile.
So, to put it simply, the fabric notation is just a map. It's the what of our blueprint. It tells us, this is the pattern we need to create. You could say it's the single most important instruction in the whole process. Okay, so that makes sense, right? The notation is the what. But how do we actually make it? Well, that brings us to the next part, the machine's instructions. All right, shift your eyes to the middle section here. This is the cam arrangement. See those columns of arrows or chevrons? That is the logic. These are the commands that take our pattern, that drawing we just looked at, and translate it into actual physical actions for the knitting machine. Every single one of those arrows tells a specific part of the machine exactly what to do and when to do it. Think of it like this. The needles in the machine travel along a track, and that track is like a landscape full of hills and valleys. These little chevron shapes, they create that landscape. They tell the machine to build a hill right here, to force a needle up to grab the yarn, or to make a valley right there to pull it down and form a loop. It's literally the brain of the whole operation, turning a simple drawing into mechanical reality.
So we've got the pattern, the DNA. We've got the brain, the instructions. The last piece of the puzzle is, well, the physical tool that actually does the work. Let's call them the weaver's hands, the needle arrangement. Now, check out this grid on the right. This is the needle arrangement. It shows us the physical setup of all the needles. It's basically a map, telling us which needles are being used and in exactly what order to carry out the instructions from the brain, from the cams.
So those numbers you see in the grid, 1, 2, 3, 4,